In 6.11, we're going to continue from what we did in 6.10. So we're still solving for sides and angles of right triangles, but this time we're going to be doing it in application problems, so story problems. So having a story, being able to set up a triangle ourselves and solve for the missing pieces. So on our warm-up, let's go ahead and pause the video and do as much of this as you can, and then we'll go through it. So as a review, the angle that we're given, that's going to be our focus angle or our reference angle. And then according to that angle, you decide which sides you have. Do I have the hypotenuse, opposite, adjacent? Which ones of those? So we have the adjacent, and it looks like we're looking for the opposite side. So the hypotenuse is there, but that's not involved in the information that we're trying to look for. So we have opposite and adjacent. So from our options, I'm just going to write it up here again, SOHCAHTOA. Make sure you know how to spell that. SOHCAHTOA. So the ones that use the opposite and the adjacent is TOA. So the O stands for opposite, A stands for adjacent. When you're writing out this equation, make sure you have tangent of an angle. Make sure the angle goes there, because tangent by itself doesn't make any sense. It has to be tangent of something. So tangent of an angle equals opposite over adjacent. And then we fill that in with the information we have. So we know our angle, which is 48 degrees, so we put that there. We don't know the opposite, that's represented as x, and the adjacent is 19. So looking at this equation right here, to get x by itself, we need to get rid of the 19. So since we're dividing by 19, we can get rid of it by multiplying by 19. So you have x left over here, and you plug that in your calculator, and the instructions say to round to the nearest tenth, so our answer is going to be 21.1 as our missing side. On this one, same idea, our focus angle, this time we're looking for the angle, but that's our focus angle, and according to that angle, we have the opposite side, and we have the hypotenuse this time. So looking at our SOHCAHTOA as a reminder, opposite and hypotenuse is using the sine, the sine function is the one that uses both of those. So again, sine of an angle, don't forget to put that angle there, is opposite. I'll write this first and then fill it in, is the opposite over the hypotenuse. So we fill in what we know. We don't know the angle, that's our question mark, so we're going to be solving for that. Opposite is 26, hypotenuse is 44. Okay, remember when we're looking for an angle, we need to rewrite this in a way that we have the question mark by itself. So getting rid of the sine, remember this time we know what the sine is, but we don't know what the angle is, so we're working backwards. So our angle is going to be, this time in our calculators, we type the inverse sign using the second button of the fraction, and that will give us the missing angle. So anytime you're solving for a missing angle, use the inverse sine or cosine or tangent, inverse cosine, inverse tangent button. So type in that in your calculator, inverse sine of that fraction rounded to the nearest tenth, we have 36.2 degrees. And if you ever have a unit, please use it. So on every single answer, and we're going to have units pretty much on every answer today because we're going to be working with story problems. Okay, so this one doesn't indicate which part we're going to be looking for. So in that case, we're just going to find all of our missing everything. So I'm going to find my missing side first. We have a lot of options for like what to solve for first. You can solve for any of these missing things. So I'm going to solve for my side first. I don't know any of my angles, so I'm going to use, since I don't need an angle, I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. And then I'll fill in 14 here. I'll fill in x here, and then 21 is the hypotenuse, so I have to put it for c. So I solve that. So I minus the 14 squared from both sides. I get x squared equals 245. And then you just take the square root of both sides. If you are asked to answer this in an exact answer, it would be the square root of 245. That is exactly what the right answer is. But if you're asked to round, you type that in your calculator, get the decimal, and round to the nearest tenth in this case. So 15.7 is our missing side. So we have that missing side. And we are still missing angle A, and angle B. So just choose whichever one you want to start with. So I'm going to do angle A. I'm going to change this up. Go for angle A first. Okay, so according to angle A, I'm going to use, since we have all three sides, I guess we can choose. I'm going to use the two that were given to us originally, so adjacent, and I'm going to use the hypotenuse. So that would be cosine. So cosine of angle A, back to SOHCAHTOA. So cosine is adjacent over hypotenuse, so we're going to put cosine of that angle is 14 over the hypotenuse, which is 21. And again, we're solving for a missing angle, so it's going to be we're going to be using the inverse cosine of that fraction. And when we type that in our equation, or in our calculators, we get 48.2 degrees. And make sure you keep the degrees, since that is our unit, since we have a unit for that one. And then after that point, you have a couple options. So for angle B, you can set up another equation for that one, or since we know two of our other angles, this one is 90 degrees, we could just say 180 minus 90 minus angle A, so minus angle A minus angle C, so that one is 48.2 degrees, just minus the two angles that you have, and that will give us our leftover, which would be 41.8 degrees, and that's going to be angle B. Oh, and I should label this as angle A. So there you go. We have found all the missing pieces. So that is solving a triangle, is when you have to find them all. Okay, let's practice setting up these problems. So for each application problem, we're going to first make a drawing. If a drawing is not given to us, then we have to make one. And then based off of that, we're going to write our equation from the triangle that we have. And then we solve. So we've done steps 2 and 3 already. Just the step 1 is going to be new for us. And in this case, when you solve, don't forget to include units of measure on your final answer. So example 1, we have someone is building a pitcher's mound to practice. It requires an incline of 12 degrees and an elevation, so height, elevation of 8 inches in height. How long will the front of the pitcher's mound need to be? So that's the question we're looking for. Okay, so we're building a pitcher's mound. We need an incline of 12 degrees. So that's going to be that side of the triangle. So it has to incline. So remember, incline is going up. So from horizontal going up, it's going to be 12 degrees. And then it says it requires an elevation of 8 inches in height. So the height is over here. And it doesn't matter if you draw your triangle exactly the same way as mine, like you could have it backwards like this. But you do have to make sure you get all of these things in the right place. So the incline has to be from the ground up. 8 inches has to be the vertical height. So that's 8 inches. And we are looking for how long will the front of the pitcher's mound need to be. So this is representing the one side of the mound. So the length of the mound is going to be up here, because this is going to be at the bottom of the mound. So that's not really what we need to look at. So X is going to be up here. So now there's our picture. And we decide the same thing that we were deciding in our warm-up. So we're looking for SOHCAHTOA. So one of these is what we're going to set up. So according to our angle, we only have one, so we're going to use that as our focus angle. We have the opposite over here, and we're looking for the hypotenuse. So opposite hypotenuse, the O and the H. This first one is the one that uses that. So sine of our angle is opposite over hypotenuse. So we're going to fill those in with what we have. So I have sine of 12 is opposite, which is 8, over hypotenuse, which is x. That's what we're looking for. And then we solve this equation. So you remember when you're solving, when x is in the denominator, you can't solve for x if it's in the denominator. So we times by x to get it out to begin with. And then I have the equation x times the sine of 12 equals 8. And now x is no longer in the denominator, so I need to get it by itself. It's being bothered by this sine 12, so it's being multiplied. So to get rid of it, we have to divide by sine 12 on both sides. So that will cancel here. And we get x equals, you plug that in your calculator. And unless it tells us otherwise, let's stick to rounding to the nearest tenth. So that's going to be 38.5. And then you have to think about, okay, what did I actually solve for just now? So you can figure out what unit it is. So we solved for the length, and looking at the other length, we're going to have the same unit. So since that was inches, this is also going to be inches, 38.5 inches. Okay. So one thing you need to know that will come up quite frequently in our story problems for the SOHCAHTOA stuff is what we call angles of elevation and depression. If you look at this picture over here, we have, if you have something that's high and you're looking down, your angle of depression is going to be from the horizontal, how far you have to look down. And then if you're standing lower, if you're like standing lower and looking up at something, again, it's from the horizontal. That horizontal is always where you have to look at. And then it's the angle, how far you have to elevate your eyes to look at something above. So the angle of elevation is going to go here. Angle of depression would go here. So again, that's what we have to, and then you would create a triangle. So we can create a triangle up here in this corner, or you can create a triangle going this way in this corner. So from the horizontal, if you look up, the angle from the horizontal to your line of sight is called the angle of elevation if we're looking up. And then if we are looking down, the angle from the horizontal to your line of sight looking down is called the angle of depression. So always go from the horizontal. That is so, so, so important. I'm going to underline that because it's always from the horizontal. Okay, this one we have a picture for, so that's good. A camera on top of the fire tower sights a ranger. So angle of depression is 40 degrees. So you notice we have labeled this as 40 degrees because it's from the horizontal and it's an angle of depression. But also when you mark this, know that this angle, you have a couple different things you could do. You can know that this side and this side are parallel to each other because they're both horizontal lines. So using alternate interior angles, you can know that this angle will be exactly the same. So angle of elevation and angle of depression will be the same angle if you're looking at a picture like this, okay? You can also say, since I know that's 40 degrees and I know this is a 90-degree angle, you can solve for this angle right here, which would be 50 degrees, since that together would be 90. But I'm just going to use my angle of depression, and I'm going to mark my angle of elevation as the same, and then just use it from there. So from here, we're on to step 2. We decide, okay, which equation am I going to use? So 40 degrees, this is my focus angle because it's in the triangle. We are looking for this one, which is the adjacent side, and we have the opposite. So adjacent, opposite from SOHCAHTOA, seems like TOA is going to be the one. So tangent of, do we know the angle? Which is yes, 40 degrees equals opposite on top, which is 45, over adjacent on the bottom, which is x. And then we solve. Again, you times by x to get that out of the denominator. And now to get x by itself, we have to divide by tangent of 40. Since it's being multiplied by tangent 40, you type that in your calculator, and you get x equals 50. Oh, and it says round to the nearest foot, so that tells us somewhere different. So 54 is going to be rounded to the nearest foot. So there we go. Even tells us what our unit is this time. Okay, example 3, we're going to have to draw our own picture for this one. So we have a ramp that is used for loading equipment from a dock to a ship. So ramp, we'll say that's our ramp. The ramp is 10 feet long. So we know this is going to be a 10-foot long ramp, and the ship is 6 feet higher than the dock. Okay, so let's make our triangle this way. You always have to make a 90-degree angle, either with the ground or with the height. So straight up and down, it says the height is 6 feet higher than the dock. What is the angle of elevation of the ramp? So remember identifying angle of elevation, depression. So of these two that we're looking at, it has to be the one that is next to the horizontal line. So the only horizontal line we have here is this guy. So horizontal elevation, so from here, how far it's been elevated, that is what we're looking for in this case. So we'll put our X right there. Okay, so according to our angle, we have opposite, we have hypotenuse. So from our SOHCAHTOA, the SO is the one that uses both of those. So sine of our angle, we don't know the angle, that's our X, equals opposite over hypotenuse. And then again, reminder, how do we solve for a missing angle? We're going to rewrite this equation, and we use the inverse sign since we have to go backwards to find our angle. And then this one doesn't say where to round, so we're going to round to the nearest tenth. So this is going to be 36.9, and what's our unit? What did we solve for? Degrees, because we solved for a missing angle. Okay, example 4, we have a picture on this one. We have a person, it's all labeled as well. So the question is, what is the angle of depression? So they've labeled that here because it's from the horizontal. Remember, depression is the angle that's going from the horizontal down. But remember, that angle of depression is the same as this angle of elevation. So if I find out what this is, since that's a part of our triangle, that will tell me exactly what size the angle of depression is as well. So from this angle, since that's the one we're focusing on, we have opposite, we have adjacent. So of our SOHCAHTOA, TOA is the one that uses both of those. So we have tangent of our angle X equals opposite over adjacent. And then since we're solving for a missing angle, we use the inverse tangent of that fraction, 285. And we end up with X equals, and this one says rounded to the nearest degree. So be very careful when it gives you specific places to round, because you could get the answer wrong, especially on your assignment. So this is going to be 28 degrees as our angle of elevation, which also is the same as the angle of depression. All right, example 5. This has a little bit of extra information in it. So the problem is a little bit different. So we're going to have a 6-foot-tall surveyor. So we have this surveyor there, it's 6 foot tall, so we start with that, is standing 50 feet away from the base of a large tree. So we have that, and we have a large tree. We'll say this is our tree over here. So if you notice, that is going to be kind of a little more difficult to make a triangle out of, but we will figure this out. Okay, so we know these are 50 feet away. The surveyor measures the angle of elevation to the top of the tree. And so when you're using a surveyor, it's from here. It's on a stand. So the surveyor measures the angle of elevation to the top of the tree. So from here to here, so this is kind of where our triangle is going to be 71.5 degrees. So from the horizontal, remember, angle of elevation has to be next to the horizontal line. And then the question is, how tall is the tree? So far, we can only figure out, like, what we've been using with SOHCAHTOA. We can only do that with the right triangle. So I'm only going to focus on the right triangle here. I'm going to put X over here because I'm trying to figure out how tall the tree is. But once I find X, I have a little bit more to do. So of this triangle, let's move this up because that's part of the triangle as well, because that's the same distance. So 50, 50. And then here we go. So we have our angle of focus right here. So we have our adjacent and we have our opposite. So of that, TOA is going to be the one to use. So tangent, we know the angle this time, equals opposite over adjacent. We solve this. Getting X by itself, we times by 50 on both sides. So we get X by itself equals 50 times the tangent of 71.5, and that gives us 149.4 for rounding to the nearest tenth. But remember, that just represents our X. It's not the full height of the tree. We also have to add this piece right here, which is a height of what? 6 feet, because if you look at this other side, you can see that it is 6 feet. So we take that, we add 6 to it, and then we get our full answer for the full height of the tree, which is 155.4 And feet, don't forget the unit. Okay, so I'm gonna post the answer for this one on the answer key, so make sure you check that. But I do want you to try example 7 because it's very similar to the one that we just did. Because we have a 3-foot tall boy who is flying a kite. So it's the same idea. We have a kite, lets out 300 feet of string. So go ahead and try this one, pause it, try it, and then check your answer. This time our triangle is like this, very similar to what we saw before. Angle of elevation from the horizontal is 38 degrees. Assuming that the string is straight, how high above the ground is the kite? So it's, again, we're looking for the height for x, but remember, after you find x, you're going to have to add 3 feet onto that. So set up your equation. This time we are looking for opposite, and we have the hypotenuse. So this is going to be so, which is sine of our angle, which we have. The angle is 38, is opposite over hypotenuse. Solve for x. And then x equals, for us, 184.7, rounded to the nearest tenth. But then that x represents that guy. So the full height above the ground is 184, and we're going to add 3 feet. So our final answer is 187.7 feet off of the ground.